We talked about this kind of briefly yesterday. If you talk about a two-dimensional shape, and we were converting the area of a two-dimensional shape, so centimeters squared to meters squared. Remember, we were talking about for each width, there was 100 centimeters, and then there was 100 centimeters going back as well. So it was 100 times 100, the width times the length. When we have the unit for area, we use squared. So it'll be centimeters squared, meters squared, millimeters squared, okay, or just units squared if they don't give it to us. That's the area of a rectangle. I'm sure you remember that from year 5 and 6. This is revision, but do just put in your notes just in case. Now, another area we need to look at is the area of a parallelogram. So a parallelogram would be a rectangle that's pushed out of shape. It has the same dimensions, so the length are going to be the same and the width is going to be the same, but it's just pushed out of shape, so it looks something like this. Now you do notice that in a rectangle we are stuck with 90-degree angles, so you know your angles, they're all 90 degrees, and I can mark them like this. If I mark lengths the same, if I give them the same little dash here like that, that means they're the same length. And so therefore this would be, just mark them the same. That doesn't mean that this one is twice as big as this, it just means that these two are the same. So that's how you show that in mathematics. So that means this length would be the same as this length in a parallelogram, and this length is the same as this length in the parallelogram. We can also draw an extra symbol on a parallelogram if we want. You can also put it on a rectangle, but it's this arrow. And we see two lines that have both these arrows. What does that mean when this, does anyone know? We can type it in the chat or turn on the microphone. Yeah, they're parallel. So hence parallelogram. This line is parallel. What does parallel mean? I can't remember.
If they like go on forever, they will like never touch.
Yeah, they'll never cross. Yeah. So most lines are not parallel. They will eventually cross at some stage, but parallel lines will never meet. They'll always maintain this distance between them. Okay, so these two are parallel to each other, and these two are parallel to each other. In a parallel, the two widths are parallel and the two lengths. Now we just need to know the area. Now the area is a similar formula, but it's the length multiplied by the perpendicular width or height. So we cannot use this slanted height. We must find the perpendicular height, which will be given to us in most questions. So we need to know what's the straight up height of this. And that is what we use to measure. So we're going to call that h in this case. So the area of the parallelogram is its width multiplied by its perpendicular height. So perpendicular height means the straight up height, the actual height, not the slanted length here, the actual height. So that'll be a different measurement to this. Usually the perpendicular, well, always the perpendicular height would be slightly less than the slant height, the direct. So we need this thing, and that's given to us in most questions. Okay, so I'm sure you've maybe come across that before, but if not, that is how we form the area of a parallelogram. So make sure it's in your notes. We're also going to look today at the area of a triangle. Now, something interesting about a triangle is, of course, if we draw a triangle, we know that a triangle, if I put another triangle the exact same here, it would form a rectangle, wouldn't it? So 2 triangles is a rectangle. Now, often the way you see this written is half the base multiplied by the perpendicular height. You probably have heard that before. And that comes from, because not all triangles are going to have a right angle. But all triangles would form a parallelogram if you completed them. So it's just half of this formula. So a parallelogram can be split in 2, and then you got a triangle. So that's where the formula comes from. So the area of a triangle also uses the straight up height. Now in this case, I have drawn a right angle triangle, but if it's not a right angle triangle, such as a triangle like this, you would use the base. And multiply it by this height, which would be marked off the triangle. So it's the perpendicular height. Or if it is a right angle triangle, you have the perpendicular height. Of course, perpendicular means that 2 lines meet at 90 degrees or a right angle. So I imagine you have heard about that before. So this is just revision, I hope, for everybody. So the area of a triangle would be half the base times the perpendicular height. And of course, the base is just going to be what would be the width of this parallelogram. It's just this line here. So it's the same, it's just half. And that makes sense because a triangle is half of a parallelogram or a rectangle. Okay. So hopefully that is not new to you guys. What about compound areas or compound shapes? Does anyone know what a compound shape or area is?
Is it a 3D shape?
No, it's not 3-dimensional. It's still 2-dimensional. Okay, I'm gonna discuss that in a second. I'll just give everybody another 20 seconds or so to complete their note on this page. So just to review as you complete, the area of a triangle is half the base by the perpendicular. I never wrote in height. Half the base by the perpendicular height is a straight up height. The area of a parallelogram is its width by the perpendicular height. And the area of a rectangle, which is width times length, or length times width. Doesn't matter which you write first. Charlie.
I think this is what your notes say, but just to clarify, on the first area of a triangle, wouldn't you just draw basically the other half and then do the area of the rectangle and then half the answer?
Yeah, that's another way of doing it. Yeah.
Okay, thank you.
So both these, I've just drawn 2 types of triangles here to show you. This is a right angle triangle, and this is just a scaling triangle where I don't know. So scaling means different lengths. All the sides have different lengths and all the angles have different sizes. And I'm not just entirely sure, but I need the perpendicular height. That's the key one. All right, so does anyone need me to hold this for a second? Just put up your hand if you need me to hold it. Or can I move on? Okay, it's a few people. All right. Okay, so for most of these, and you can continue to take these down in the notes, I'll just do a couple of examples here at the end that you do not need to take down. If I have a rectangle of length 10 and width 5, or 5 and 10, the area to that is just going to be 5 times 10, of course. 5 times 10, because if you think about it, if you want to split it up into blocks, which you don't have to, there'd be 10 centimeter squared blocks along the end here, and then there's 5 rows of them, so you got to do 5 times 10, if you want to think about it like that. So that'd be 50, and if you don't give a unit, you can just say units squared like that, or squared units. as an example, or usually they would give a unit in centimeters or meters. If I wanted to find the area of a triangle, and I have a triangle like this, so once again, you don't have to take down these examples, you can just watch. Let's say I'm given loads of information on this. I'm given 3 centimeters here. This length here is 5 centimeters, and this length here is 7 centimeters. Can I work out the area for this? Does anyone know the area, or anyone can type the area in the chat? No one can type the area in the chat.
What is the number of the right side?
Okay, so yeah, there is no perpendicular height here, so I can't work it out. It is not half of 3 times 5. 5 is a slant height. It's not its straight height to the ground. So I need that straight distance back to where the base is. And I need this height. So the question would have to give, and that for this question is 4 centimeters. So now, what is our area? Can anyone type the area in the chat of this rectangle here? Okay, so it would be, well, 3 and 4 are the 2 dimensions we are looking at. So 3 is the base here, and 4 is the straight up or perpendicular height. Yeah. So you can put it into formula half, and sometimes it's easier to just do the base times the height first and do half the answer. 3 times 4. So 3 times 4 is 12 and get half of it, and that is 6. Or you can do half 3, which is 1.5, and 1.5 times 4 also gives 6. Or you can do half of 4. So remember, multiplication works in any order. This half is just multiplied by these 2. Or half times 3 times 4. You can do it in any order and you get the same answer. So if it's easier to half the 4, half of 4 is 2, and then do 2 times 3. That's okay. So remember, this bracket just means multiply. So it could be written a half multiplied by 3 multiplied by 4. Either way is fine, and either way you get the same answer. So once again, you're going to need a calculator for this unit, because although this is an easy example, some of the questions are going to get more difficult. And I'm not testing your multiplication skills in this unit. I'm testing your ability to apply formulas and solve some problems. Okay, so you don't need these 2 in your notes. I'm going to move on to something called compound shapes, which may be new. Compound shapes. So do take notes on this. Yeah, that's correct. Yeah. Yep. You're still all about the algebra. Yeah. Okay. So an example of a compound shape. That is a simple example of a compound shape. Yeah, 2 or more shapes that make one. Okay, so if I wanted, I could add on that. And we will be adding on to that perhaps later on in the unit. There'll be semicircles coming out of this, and all sorts of things. But this is a compound shape. So it's 2 or more shapes compounded or put together. So it's compounded, they're kind of stuck together here, they're joined. So that's a compound shape. So if I wanted to find the area of this shape, I need some information. I'm going to say that it is 10 centimeters in height. This part, just this part from here to here, is 6 centimeters. From here to here. And it's got a width of 5 centimeters. So let's see, can anyone figure out how what the area for that is while I do it here. So this is the question. Find the area of the above shape. That'll be the question. You were too quick off the mark there. So two separate shapes combine to form this shape. Often they won't draw this line in the middle. You will have to put that in for them or for yourself. So if there's two separate shapes, I can just take them separately. There is a rectangle here. I've just redrawn this. That's 6 centimeters and 5 centimeters. Okay, that's, well, it's easy to find the area for that. That's 6 times 5. That's 30 centimeters squared. So that's the area of just the rectangular part. I also have a triangular part. That here, I think a few people have the answer correct. Now the triangular part, well, we're missing some dimensions here. The base I can work out because I know the base is stuck on and it's the same size as the base of the cube is very certain it's 40. Stuck on here. So this is a base of 5 centimeters. But I don't have this height here. But I have enough information to get the height. I need to know this height from here to here. From here to here. I know the total length is 10 here. But I also know that this bit is 6. Up to here is 6 centimeters. So what's left over here? There's 4 centimeters because it has to all add up to 10. So there's 4 centimeters for this bit. Okay? And this is a right angle, so that's a straight up height. Okay? So 5 times 4 gives 20, yeah, but it's not a rectangle, so I gotta half it. So the area of this triangle is a half multiplied by 5 multiplied by 4, the same as what we had on the other page. A half the base times the height. A half times the base times the height. So I can do this in any order I want, because multiplication can be done in any order as long as they're all multiplying. It's easy to just multiply these two, isn't it? This is a half times 20, or a half of 20. Half times 20 is 10 centimeters squared. So I've got the area of the two things separately. 30 centimeters squared for this. This is 10, I nearly wrote 20. 10 centimeters squared. So combined as one compound shape, their area is this plus this, which is 40 centimeters squared. Total area, I call it, of the compound shape. Yeah, there's many ways you can write this. You can, so the area of a triangle, it's just, don't need to know the word for it, it's just a commutative property of multiplication. Yes, you can do, dividing by the half is the same as, or dividing by 2 is the same as multiplying by a half. So if you find it easier to write the area of a triangle, base times height, and then half it by dividing by 2 instead of multiplying, that's perfectly fine as well. If that's an easier way of doing the area of a triangle, go for that. So maybe if you want to write that, you can either. Okay. So you just half it. So notice that half times 20 is a half of 20. Remember, multiplication means the word of. A half of 20. So you always read multiplication as the word of. If you're confused what it means. Okay. Or you can just do what it would be as a rectangle and half the answer, yeah, which is this. Okay. So that is the conclusion of the notes for today. Now, before you go, you have to do 2 things with the remainder of the time. First thing is, if you have not finished yesterday's work,